Welcome to Mastering Solutions. In this free fall question, they ask us about a student who throws a ball from the top of a building. And they say that she throws two balls, ball A and ball B, and she throws it from the same height, but one of the balls she throws straight up and one of the balls she throws straight down with the same initial speed. So we'll say that she's up here on the top of this building, and we'll say from here all the way down to here is the height of the building. And when we throw ball A, she's throwing it straight upward, and we'll say it's V naught for the initial velocity. So this is going to be vector A. And then downward, she's going to throw ball B with the exact same initial velocity. So for part A, what they're asking about is the accelerations. And so they say in direction and magnitude, we want to compare the two immediately after they leave her hand. So the acceleration after they leave her hand, they're in free fall, right? This is a free fall question. And so when we say that, the only thing that's acting on these balls now is gravity. So for ball A, we could illustrate gravity like that for G. And in ball B, gravity is also going down like this. And so since the only thing that's acting on them is gravity, the magnitude and the direction of the acceleration velocity is actually the exact same. So we can put equal. Now for B, they want us to compare the final speeds now. So now we're talking about velocity as they reach the ground, and they want to know, is one larger than the other, or are they equal? Now, with this question, we're going to ignore air resistance, because that could actually change our answer a little bit. But conceptually, when we talk about it without air resistance, if we think about ball A going up, it's going to go a little bit slower and slower because gravity is acting on it until it's going to stop at the top. And then gravity is still acting the exact same amount. So it's going to go a little faster and a little faster and faster. And so right here, it's actually going the exact same speed as B. Since they're going the exact same speed when B leaves her hand and when A reaches this point again, when they hit the bottom, they'll also be going the exact same speed when they hit the ground. Now, if air resistance were a factor, then maybe that would change it, because we'd lose a little bit of the velocity due to air resistance as it's going up, and then a little bit of the velocity due to air resistance as it's going down. So they might actually be a little, subtly different. But for this case, since we're ignoring air resistance, both the answers A and B will be equal.